morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to start with Chapter 8, guys. We're going to talk about simplifying rational expressions. The good news is if you know how to factor, this chapter becomes a lot easier. The bad news, if you don't know how to factor, this chapter is going to be extremely difficult. It's going to be quite a nightmare for you. So I do strongly suggest that if you are not strong with factoring, that you review and relearn your factoring techniques and skills, please, and thank you. What is a rational expression? Well, a rational expression is the quotient, that's a division, of two polynomials. Think of the following rational expression, okay? Think of it as ratios, okay? It's a fraction or quotient of polynomials. For example, I've got x squared plus 2x minus 3, that's a trinomial, divided by x plus 3, that's a binomial. When I have a polynomial divided by a polynomial, that's a fraction or a ratio made up of polynomials. That is called a rational expression. Whenever we have rational expressions, we want to express the rational expressions in simplest form. And a rational expression in simplest form occurs when its numerator and denominators are polynomials that have no common divisors. When we can simplify those polynomials no further, that's when we have a rational expression that is simplified completely. For example, over here on the left, circled in blue here, these are polynomials that are simplified, simplest form. These are rational expressions that are simplified. For example, x plus 1 divided by x minus 1. You cannot simplify that anymore. Now, let's eliminate all myths and all misconceptions. Someone may say, Mr. Morrow, you've got an x and an x. Can't you just go blammo? And then 1 divided by 1 is negative 1. Doesn't that equal negative 1, Mr. Morrow? Absolutely not. 100% no. That is inaccurate. Please do not do that. You cannot, and I repeat, cannot simplify individual pieces of polynomials. I can do this if I have an x plus 1 times an x plus 5 divided by an x minus 6 times x plus 1. I can absolutely get rid of this x plus 1 and this x plus 1 because I can eliminate perfect polynomials from numerator to denominator. But what I cannot do is I cannot eliminate individual pieces of polynomials. I cannot do that. So let me get rid of that because I cannot get rid of the individual x's. I can get rid of exact polynomials, but I cannot get rid of individual pieces. So that is fully simplified. The next one, x squared plus 3x plus 2 over x plus 3. Well, let's see if this is fully simplified. I say it is, but who cares about what I say? Let's see what we can prove. Let's factor this out. The numerator I can factor out what times what is 2, but when added together is 3. This is x plus 2 and x plus 1 over x plus 3. Can I simplify anything out here? No. For anyone that's still tempted, Mr. Morrow, I can get rid of this x and this x. No, you cannot. You cannot do that. So this is completely simplified. I cannot factor anything else out. I cannot simplify anything else. Yes, sir. You can leave the answer like this or like this. Yes, sir. But you're going to have to factor it out to see if it is simplified or not, sir. Thank you, my brother. Yes, sir. If the x plus 2 is an x plus 3, then I could cancel out. Yes, sir. Correct, sir. Now, not in simplest form. These guys over here. Okay? Well, x divided by x squared, that's not in simplest form, right? Because I can go ahead and simplify that to what? 1 over x, very good. That's simplest form now. Here, I have an x minus 3 times x minus 3 over x minus 3. I can get rid of this whole x minus 3, and that leaves me with 3. Now it's in simplest form. This top numerator can be simplified to x minus 3 times x plus 2. The denominator can be factored out to x plus 2 times x minus 1. Now I can get rid of the x plus 2's, and now I'm left with x minus 3 over x minus 1. Now it's simplified. Okay? So simplified rational expressions only occur once I have factored the numerator and the denominator, and I have eliminated all common polynomials. I'm not trying to be sarcastic. I need you to understand this clearly. You can only eliminate common polynomials. If it's a common monomial by itself, great. If it's a polynomial, though, it has to be exact polynomials. And I cannot take away individual pieces of polynomials. Everyone understand that, my brothers? Yes, sir.
Like x squared.
But what I mean by that, if I have, let's say I have an x squared here, but I've got an x plus 4, and then I've got x times an x plus 3. Okay. These guys here are monomials, right? So I can get rid of one of those x's, correct? I can get rid of one of these and this guy. So now I'm left with x times x plus 4 over x plus 3. That's it. I'm done. I cannot do anything further. Moral, can't I get rid of this x and this x? No. Why? This is a monomial outside of the polynomial. This is a binomial. The only way I can get rid of this binomial is if this was a 3. Does this make sense, guys? It's a brilliant question. Thank you. Guys, talk to me. Yes, sir. If I distribute the x, then I complicate it again. Then I go back to x squared plus 4x over x plus 3. I'm trying to simplify this, not make it more complicated. The whole point is just to factor, not remultiply. Thank you for listening. Does that make sense, gentlemen? Okay, thank you, my brothers. And like I already described, you simplify a rational expression by dividing out the common factors in the numerator and denominator. Factoring the numerator and denominator will help you find the common divisors. And literally, that's it. So let's get to work. So I want you to simplify all of these. Okay, so let's factor. So the numerator, good job. X plus 5 and x plus 2. Beautiful. Well done, my brothers. And in the denominator, what times what is negative 10, but when added together is negative 3? Negative 5 and positive 2. Okay. Which here, okay, whoever said the answer is negative 1, that's wrong. You guys aren't even thinking, and you totally ignored what I said. So please, guys, let's think before we speak. I'm not upset at all, but I do not appreciate you jumping the gun. Wait. Doesn't this x plus 2 and this x plus 2 go bye-bye? Yes. Okay. Whoever said the answer was negative 1, this is what you did. You canceled out these x's. Is that a legal math operation? No. So whoever said negative 1, I'm sorry, but no, you're wrong. This is x plus 5 over x minus 5. Those are not identical polynomials. You're done. You cannot simplify any further. Done. Does that make sense, guys? Please. Whoever said negative 1, does that make sense to you? Please. I'm here to help you. Why? Why does that make sense, sir? This is a polynomial. This is a binomial, x plus 5. This is a binomial, x minus 5. I cannot take away individual pieces of polynomials. This is an x plus 5. This is an x minus 5. I cannot just get rid of those x's, because those x's do not really exist by themselves. This is an x plus 5. This is an x minus 5. No. Well, if this was negative x minus 5, then I could factor out a negative from the bottom. and then this would be an x plus 5 here. Then I can cancel these out, and then that would be a negative 1. But that is not the case here, sir. With all due respect, I can't just magically put negatives everywhere. This is an x minus 5 here, sir, and that's a polynomial. Now, if I had x squared, x plus 5, over x times x minus 5, these are monomials. I can work with monomials. This x goes bye-bye, one of these x's go bye-bye, then it'd be x times x plus 5 over x minus 5. But this is a binomial, this is a binomial. I can now only cancel that out with another perfect binomial. Does that make sense? You promise, gentlemen? Thank you, my brothers. Thank you, thank you, thank you. Thank you for your honesty, sir. Okay, let's move. Okay, let's work with the numbers first. What's 24 divided by negative 6? These are all monomials. This one's easy. Negative 4. Okay, I got x cubed and x squared. 2 from there, 1 from here. Left with an x. Y squared over y cubed. This is old stuff. Get rid of 2 from there, 1 from here. I'm done. Number 3. Let's factor. Okay, I've got x, let's see, plus 6 and x minus 2. And in the denominator, I got, not a 6. Come on, Mr. Morrow. Pay attention, Mr. Morrow. Thank you, gentlemen. And in the denominator, I've got x minus 3 and x minus 2. Okay, which are the perfect polynomials that I can get rid of?
X minus 2.
Thank you. An x minus 2 and an x minus 2 are identical polynomials. See you later. Have a good day. I'm left with x plus 4 over x minus 3. I cannot do anything with those because those are two binomials that are not identical, and therefore I cannot cancel individual pieces out of those binomials. Number 4. Okay. Whenever I have it in a situation like this where I have 12 minus 4x, I always want to get the lead coefficient to be positive. I always want the x in the beginning of the polynomial, because I always want it in standard form. I don't know if you guys remember that term. Standard form of a polynomial, I go from highest degree to lowest degree. So the first thing I want to do is get this x in the front of the polynomial and as a positive. So how would I do that? No, you don't. Well, yes, you factor out a negative 4. Thank you. So I take out a negative 4, and now I'm left with x minus 3 over, this is a difference of squares. So what does that factor out to? I am so proud of you, son. X plus 3x minus 3. The x minus 3 cancels out with the x minus 3, and this equals negative 4 over x plus 3. Bada bing, bada boom. Beautiful. Well played, my friend. Well played. Does that make sense, my brothers? Awesome. Thank you. Yes, sir. No, that's why we have a recording, sir. Thank you, sir. Okay, now, next thing we have to learn in this lesson. Not only do we have to simplify, but we have to know how to recognize what's called undefined values. If you remember from back in elementary and middle school, you have what's called undefined values. When you have 5 over 0, that is called undefined. 0 divided by 5 equals 0. But anything over 0 is undefined. It doesn't exist. It's not real. It just doesn't exist. It cannot happen. Nothing can be divided by 0. Nothing. So in order to find or determine the values for which a rational expression is undefined, very simple, my boys. Set the denominator to not equal 0. That's what I want to find. I want to find what values of x are going to make the denominator equal to 0. And those are the values of x that cannot be valid. So when I look at this expression, 2 over x plus 3, and I want to find or determine the values of x that are going to make this undefined, I just go, oh, okay, x plus 3 cannot equal 0, so x cannot equal negative 3. So what are the values of x that are going to make this undefined? Negative 3. When x is negative 3, this is undefined. That's it. How about here? I've got this down here, so I factor it. I've got x minus 3 and x plus 1. Simplify and determine the values for which the rational expression is undefined. Well, set x minus 3 to not equal 0 and x plus 1 to not equal 0. So x cannot equal 3 or negative 1. So what are the values for which the rational expression is undefined? X cannot equal 3 or negative 1. You factor, and then you set the denominator to not equal 0. You had a question, son. Thank you. Number 3, same thing. Simplify and determine the values for which a rational expression is undefined. Well, factor the denominator. In this case, it'd be x plus 3 and x minus 1. Set the denominators to not equal 0, because those denominators cannot equal 0. So x cannot equal negative 3 or 1. So what are the values of this rational expression for which this is undefined? When x is negative 3 and 1, this rational expression is undefined. So x cannot equal negative 3 or 1. I will finish the video. You guys enjoy lunch. Have a wonderful day. Okay, next. So, simplify and determine the values for which a rational expression is undefined. So let's factor this numerator. I've got take out a 7x. So I've got x plus 2. Give me 1 second, please, and thank you. Okay, guys, and now let's, you can't factor out the denominator, okay? Now, a lot of people go ahead and they start simplifying before they express the undefined values. But the trick here is always to do the following. Factor first, find the undefined value second, okay? Then step 3, then simplify. Because a lot of times what happens is after people simplify, they will get rid of factors, they will get rid of denominators, and then you forget to add those as the undefined zeros. So we factored. Now let's find the undefined values. Well, set the denominator equal to 0 or not equal to 0. So 49x cannot equal 0. Divide by 49. So x cannot equal 0. So that is my undefined value. I have already found the undefined value. Simplify now. Okay. Well, 7 goes into 7 one time. 7 goes into 49 7 times. This x can cancel out with that x. Why, Mr. Morrow? Because those are monomials. It's just one term by itself. Those can cancel. I cannot cancel out with this x, but I can cancel out with this x because it's outside. So my answer is x plus 2 over 7 with an undefined value of x cannot equal 0. And last but not least, let's just do a little practice round here, and I'll let you guys go. So here we've got 4 terms. Don't forget your factoring skills. This is grouping. So let's group this bad boy. I can factor out an a from here, and I'm left, and actually an a squared, so I'm left with a plus 3. From here, I can factor out a 2, so I have an a plus 3. So that I'm left with a plus 3 times a squared plus 2. Please remember your factoring skills. The denominator factors out to be a plus 3 times a plus 3. Set the denominators not equal to 0 to find my undefined values. So a cannot equal negative 3. That's my undefined value. And now simplify. An a plus 3 cancels out with an a plus 3. So my answer is a squared plus 2 over a plus 3. I have my simplified answer, and I have my undefined values. Number 2. Hey, this is a perfect square. That's 2x. This is a perfect square. That's 1. 2 times 1 times 2 is 4. That's a perfect square trinomial. It's positive, so that's a plus. That's squared. Over. That's a perfect square. That's a perfect square. They're being subtracted. That's a difference of squares. So that's 2x plus 1, 2x minus 1. So I factored. Now, set the denominators not equal to 0 to find your undefined values. So I set 2x plus 1 not equal to 0, and 2x minus 1 not equal to 0. So x cannot equal negative 1/2, and x cannot equal positive 1/2. Those are my undefined values of x. And now, I have 2x plus 1 down here, and I have 2 up here, so I can get rid of one of them. So I'm left with 2x plus 1 in the numerator and 2x minus 1 in the denominator. That's my simplified rational expression. These are my undefined values. And last but not, well, 2 more. Another grouping. Group it, group it. I can factor out a y squared from the first one, and I'm left with a y plus 1. Factor out a negative 3 from the second group, left with a y plus 1. That gives me y squared minus 3 times y plus 1 over, factor out the denominator, y minus 2 times y plus 1. Now, I got to find my undefined values, so I set the denominators to not equal 0. Y minus 2 does not equal 0. I set y plus 2 to not equal 0. Or y plus 1, I'm sorry, to not equal 0. So y cannot equal 2 or negative 1. Those are my undefined values. Now simplify if possible. The y plus 1 cancels out with the y plus 1. And my simplified rational expression is y squared minus 3 over y minus 2. And there it is. And last but not least, let's factor. Remember, when I have a negative x squared or a negative leading coefficient, I want to factor out a negative and bring it to the front. So I'm going to factor out a negative 1, giving me x squared minus 4. That's a difference of squares. So this is a negative x plus 2, x minus 2 over, go ahead and factor this out. We're going to do this the Cuban method. It's 2x, 2x. 2 times negative 6 is negative 12. What times what is negative 12? Well, when added together is negative 1. You got negative 4 and positive 3. Imaginary factor of 2 here. So I've got x minus 2 times 2x plus 3. So I factored. Next step, find the undefined values. So I set x minus 2 to not equal 0. I set 2x plus 3 to not equal 0. So x cannot equal 2 or negative 3/2. Those are my undefined values. And last but not least, I simplify. X minus 2 cancels out with an x minus 2. And my simplified rational expression is negative x plus 2 over 2x plus 3. And ding dong, the witch is gone. Guys, thank you so very much. We did a lot of examples. Remember, factor numerator and denominator. Find the undefined values of the denominator. Then simplify. God bless you. Thank you. Hope you learned a lot. Have a wonderful day. Bye-bye.